I'd like to now thank another great sponsor of SBCs and the Green Building Festivals, Union Gas. Could I ask Susan Carretti, please come up and introduce our next speaker?
Thank you, Larry. Just a few quick points about Union Gas. Just on behalf of our team at Union, I want to say how pleased we are to be able to participate as a sponsor this year at today's event and to support the really great work that's being done by Sustainable Buildings Canada. As some of you may know, Union Gas is currently working with SBC to bring our Commercial Savings by Design program to the builders in Ontario and the developers of new construction projects within our franchise area. And Enbridge has a very similar program in their franchise area. So if any of you have a project that is in the very early design phase, before the key energy efficiency related purchase decisions have been made, with a minimum square footage of 50,000 square feet, you could be eligible to participate at zero cost. The full program value is up to $60,000 for participating projects, and the program consists of a visioning session that is designed to help you identify which energy efficiency issues and conditions need to be prioritized in your project, and to determine what members of your team would best work in the project development. And we bring the external experts in, and they are invited to the IDP Workshop, which is the integrated design session. It's a full day workshop. It's led by SBC, and they assemble a full team of experts to work with your team and implement your design decisions. So together, Union Gas and Enbridge and Sustainable Buildings Canada are working together to assist you in meeting and surpassing building code requirements, maximizing energy efficiency, and driving down the cost of operating the new construction. And now it is my great pleasure to introduce our afternoon keynote speaker, Mr. Bill Dunster. Bill is the principal of ZEDfactory out of London. Bill set up ZEDfactory in 1999. As a practice, ZEDfactory's projects demonstrate a step change reduction in carbon footprint that can be achieved at the same time as an increase in overall quality of life. ZEDfactory has experience working on a large range of architectural projects, varying in size from large-scale master planning to small residential refurbs. ZEDfactory has worked in Brazil, China, Korea, the Middle East, and Portugal, as well as the UK, with particular emphasis on the holistic integration of zero carbon thinking into the placemaking and transportation agenda. Bill has taught at the Architectural Association, University College London, Kingston University, Harvard, and EPFL in Lausanne, France. He also gives lectures, conducts workshops, and speaks regularly at conferences globally, as well as within the UK. He is currently a visiting professor of zero carbon urbanism at UCL and at Cardi University. The ZED book was co-written by Bill with eco-footprint expert Craig Simmons and building physicist Bobby Gilbert, a manual for achieving zero carbon development at different densities and scales, which won the RIBA Research Award in 2008. In 2010, Bill received the OBE for services to sustainable housing design. And it is my pleasure to introduce Bill Dunster.
Well, thank you very much for inviting me to speak. It's been a truly remarkable day so far, and I've learnt a lot. This is very much the after lunch slot, so I don't mind if you get up, get more coffee, go to the loo, do whatever you need. And I also don't mind heckling. So anyone who wants to give me a really hard time, they can. And probably it's that the lights are a little bit bright for the after lunch slot, if they could come down. ZED stands for Zero Fossil Energy Developments. And what I'm just going to do quickly is explain who I am, where I've come from, and what I used to do. I spent 14 years working for Michael Hopkins and Partners, which is a big London architectural practice. And this is one of the most important projects I worked on for about 6 years of my life, which was a new underground station and offices for MPs right opposite Big Ben in Westminster. And what's interesting about this thinking is how this is in the mid-1990s. We were really trying to understand the new building physics model, which completely changed the design of modern architecture. We wanted to see how heat recovery, ventilation, and air circulation, how shading, daylight levels, how all these different parameters could be juggled to optimize the building fabric and create a new language of architecture. We didn't succeed in all respects, but these are starting to be interesting progression towards a contemporary vernacular. And I think that's important because when I walk around many international cities, all I see is a developer simply elevating his plot at the maximum plot ratio the planning department will allow him to get away with. And you just see a series of cubes of different heights depending on how many planning officers they took out for lunch. And I think, sorry, I'm being very rude, but there is more to the design of cities than lunching, and not much, but some. And there are various principles which the Canadian Green Buildings Festival is really examining, and really the key thing seems to be how do we achieve an architecture which is at best climate neutral. In other words, it doesn't contribute to accelerating climatic change. So I'll just finish by saying this is a university campus that I designed, competition we won again at the end of the 90s. And I left the office I was working with because my boss said, it's just a very big garden shed. And what happened was there was a fight, an aesthetic battle in London in the late 90s between the old proponents of good old-fashioned modernism with plate glass windows, as many as you could see, perhaps a little bit of the British high-tech movement, lots of dangling cantilevers and tensile struts of the kind you still see Richard Rogers dangling away, and then there was the idea that you had to change architecture and produce a completely new language. So the staircase that you see in this slide is actually the return air path that joins up to all the corridors inside these academic faculty buildings for Nottingham University, and takes the return air up to the top of the stair, and it goes into a thermal wheel, which is a very large heat recovery unit. And it also has a bypass so that the buildings can naturally ventilate when heat recovery is not appropriate. Now these are all really major form generating factors, which I just don't see many architects really engaging with. So here you've got an atrium, which is spaced between two very rational domino frame concrete slab academic faculty buildings, with the edges of the atrium transparent to allow daylight to the rooms below, and the middle band is covered in solar electric panels, glass laminate, which was extremely expensive in the early 90s. But that area of photovoltaics is enough to power the air handling and the heat recovery unit. And because we got these very low pressure drop air distribution, which is those green ducts coming out the bottom of the silver box at the end of the atrium, and they feed a pressurized floor plenum, and we only achieved 0.35 watts per litre of air handled. So this was a mixed mode building which could be naturally ventilated at mid-season, but mechanically ventilated in the winter, and if necessary, a bit of passive cooling in the summer. And then I had this revelation at one stage when we built this very energy efficient university campus. It was actually a brownfield site on an old bicycle factory. And one day, of the many sort of days spent walking around the site, I noticed that all the university lecturers had arrived, and there was a sea of Volvo estate cars, which completely took over the whole car park. And I then realized that actually there was literally no point in designing energy efficient buildings if you didn't address the integration of transport and all the other ecological and carbon footprint issues that are related. So here you can see the first sunbathing island in Nottingham in the middle of a large rainwater storage lake. And so we then built a house following that project to try and show how we could do everything better if we were the client, and my poor wife was the clerk of works, and spent most of her time chasing small builders in and out of the local public house, which is how you get buildings built in the UK. But you can start to see how some of these ingredients come. There's a large red shear frame which takes the wind loads, but also lets very large amounts of solar gain deep into the plan. It was designed in a flood zone, and every year I'm nearly flooded. We never quite get there, but we did come in with all the services at high level. They come down, and the walls of the ground floor are internal brickwork inside and out, with styrofoam insulation built into the wall, so it's possible for it to be hosed down and be back in action perhaps a couple of weeks after a major flood. Now, this was all designed in the early 90s, and we found that at the time it was regarded as a complete joke. Climate change wasn't really discussed at conferences like this in the early 90s. And it just didn't come on the agenda at all. And the fact that there was going to be overheating and so on was really unheard of. Couple of years ago, virtually the entire Thames Valley flooded, and about 4,500 homes had exactly the same problem as us. So what we decided to try and do was set up an architectural practice which is somewhere between an environmental pressure group, an architect's practice, a master planning practice, a product designer, and perhaps a little project management. And we decided to try and develop all the ingredients to lead, to make it as easy as possible to deliver a low carbon lifestyle. And we called ZEDfactory because although we don't actually have a factory, I spend all my time visiting factories and trying to persuade them to change their products or make one component that makes this holistic proposition as affordable and easy to specify for us and other design professionals. And we did this, we set up this idea that we could move beyond architecture and get into transport and food production and really look at all the ideas of a low carbon future and integrate them into one holistic plan. And this was well before BREEAM was really going, particularly with regard to the residential sector in the UK. And we worked with WWF. We set up this concept of a one planet lifestyle, and the idea was to show that you could lead just as higher quality of life with a one planet level of resources as the current 3 planet level of resources that was being experienced and still is experienced in the UK at that point in time. So what then happened was we went around talking to social housing providers, trying to find developers, And they literally looked at us as though we were Martians. There was just no interest in this at all. And if you then explained that actually we wanted to provide buildings which made no net contribution to climatic change over their entire lifespan, that was regarded as just insane. However, now we've just heard this morning that there's a whole room of people trying to do exactly that. So we have a very simple methodology. I don't believe necessarily in too many checklists and too much interrogation of very detailed data, although monitoring is terribly important as the feedback loop. I think you can make it very, very simple. And if you minimize the embodied carbon, that's the energy used to make, or the carbon footprint used to make a project in the first place, and you minimize the running carbon, that's the energy needed to run the project, and you make sure you incorporate enough building integrated renewable energy generating devices or ideas to both meet the running demand and possibly 10% or 7% surplus each year, you can slowly pay off the embodied carbon debt over the lifespan of the project. And if you can do that, that's simple, that's a piece of carbon philosophy, you don't need to have all these ridiculously long checklists, methodologies, etc., because you either do it or you don't. So how many years is your carbon payback? So with one number, you can understand whether a building's actually really environmentally benign or not. I don't know if anyone's read The Hitchhiker's Guide to the Galaxy. There's only one number that matters at the end. I think it's... I'm not going to say it. But the point is, if you can pay back your embodied carbon debt before your building falls down, you've achieved, you have actually contributed to the sustainability or the perpetuation of the human race. If you haven't, then you're using up natural capital, and there isn't any left for you to have. So it's endgame. So this is a very simplistic but straightforward way of assessing whether you've done a good job or not. All the rest of it is frankly bullshit. Someone's got to be angered by that. Okay. I'll see you afterwards. So the idea, we then went round working with a local environmental charity called Bioregional Development Group, and they asked me to build them a green building demonstration centre with, I think their budget was £75,000, and they'd got a corner of someone's garden. And I said, well, there's no point in doing another green garden centre, because there's lots of those at the moment. Why don't we try a complete residential community which actually showcases how you can lead this low carbon lifestyle? And we approached the Peabody Trust, which is London's oldest housing association, and put all these ideas together and decided to design a living, working residential community. Unfortunately, the site we'd identified was in advanced stages of sale to a very large house builder in the UK called Barratt Homes. And they didn't like that at all. So we lobbied and lobbied and lobbied, and we worked very hard with the politicians, and in the end, we were allowed that the site wasn't sold to Barratt Homes. We bought it for a tiny amount less money on behalf of a local housing association, and we built this project. And this project was intended to show how if the UK had to build, which it still does, millions of new homes, it could do so without building them on agricultural land and green belt. And that was important because the UK is currently importing, was then and is probably more now, importing in excess of 70% of its nutritional requirements. And often it's coming from a very long way away, such as Africa. So it becomes very important to show how you can have reasonably high density housing models which are affordable to build, are suitable for families, and are really relevant without always turning to high-rise and apartment buildings as being the only urban model worth having. Now, this has to also be remembered that 70% of the housing in the UK is 50 homes per hectare or less. So one of the things we looked at was housing we'd stayed in, and this is Georgian key workers housing in Edinburgh, which I stayed in when I was at university. And this is Repel Street, which is old Victorian social housing where you literally had one family in each room, and that's at Waterloo Station. And the idea was to show how just using the available footprint of brownfield land that was actually ready for redevelopment or regeneration, we could meet the UK's housing requirements. No one asked us to do this. This was just a way of trying to explain that there were new ways of creating communities which were not in any shape or form following what was being taught or promoted by the government at the time. And there are huge manuals written mainly by new urbanists. Do you have new urbanists here? Yes, anyway, Andreas Duani, all that stuff. Manual for streets. There's a sort of classical way of designing which was really didn't respect solar energy, didn't respect any environmental determinants that we could see at all. And then the next thing was we found that we were heavily criticised by the Prince Charles's School of Architecture, who has a mission to, or did have a mission at the time, to try to recreate Georgian England, which was probably the time when the promoters of this school of architecture felt happiest. So I've agreed. I mean, I will build a Georgian building for anybody who wants me to, but I insist that you wear Georgian clothing. So what we have here is a terribly ordinary place. It's 40 minutes, well, actually it's 25 minutes if the trains run, from London Victoria Station, which is a main line. It's a bit of land that absolutely no one had anything good to say about. It's been used for sewage treatment for over 120 years. So it has a little heavy metal contamination, mainly bits and pieces that have been through people for a very long time, but actually isn't so toxic, a few 50 or so years later. It's caused a lot of economic blight in the area because no one wants to live near that kind of smell. In other words, there's absolutely nothing going for this site at all, and it's the perfect place to design a model environmental community. Because you're only allowed to experiment in the UK if it's somewhere which nobody places any value on. So you can see that the housing that would have been built on this site in the top of this slide, and we dreamt up a complete transformation. We were going to plant short rotation coppice, have a gasified wood heat and power plant, a lavender plantation with keyhole beds for picnicking in to start to reduce the smell. We were going to regenerate the local community with introducing jobs back in, set up reverse commuting so that people came to work here again instead of just going in one direction towards the city centre every day. Start to get more of a 24-hour feel to the place. So what did the local council do? They designated these surrounding fields for gravel extraction and landfill. However, the project is built. So this is a cross-section. It's a little piece of solar city. The homes face south. In the shade zone of the homes are workspaces or live-work units, and above them, everybody has a garden. So the idea is to give passive solar gain, which on a super insulated home with quadruple glazing in the London climate, you don't actually need heating at all. If you cook a meal once a day, you have the potential for near zero heating bills. You only need some hot water for washing. So they're thermally extremely efficient. That's working very, very well. We tried to get good levels of daylight. We tried to give everyone their outdoor personal space. As climate change accelerates, then you can see the living rooms moving across into the gardens. And we tried to get a reasonable density. And we got to the point where if everything works perfectly, it can just about achieve a one-planet lifestyle, providing you don't go on a holiday to the Costa del Sol. So that's the thing that changes everything. So if you can, and I don't really feel apologetic about this. I feel we shouldn't tell people how to live, but we can set up the infrastructure and the framework that enable them to adopt this environmentally responsible lifestyle. And they should do it because they want to, because they're personally motivated, or because it's economically sensible for them to do so. And that's great, but there should be no coercion involved, because there lies eco-fascism. And there's plenty of that coming, because as climate change accelerates and environmental degradation gets worse, there will be draconian responses to disasters. The idea was to try and inhabit the site. So you started with an overgrown bramble field. We try to insert the human accommodation. We then try and relay the landscape on top. And that's what it looks like today. So you can see the roof lights are getting daylight down to the workspaces and live-work units, which are then placed in the shade zone of the housing. The buildings are aerodynamically designed so that the prevailing wind is tracked by the rotating wing cowls, and fresh air goes in the small end and preheats. The incoming fresh air is preheated through oversized flat plate heat exchangers by the outgoing stale air. So the whole thing is ventilating and breathing, and it is a genuinely nice place to live. We had the first 15-year celebration last weekend, and it was entirely run by what we call BedZED babies, and these are children that have been brought up on this in this village, and that's the only life they know, and they are completely different and completely much more optimistic and open about the future than other kids that we come across who are maybe living in quite degraded urban environments. And it also has to be remembered that this is not a wealthy community. This is 1/3 social rent, 1/3 shared ownership, and 1/3 private for sale. So this isn't for rich people. So my point here really is to say that the British suburban model, which is where a developer just goes 3 stories high, and we were restricted to 3 stories on this height, with a pitched roof, has been totally reinvented. The density is exceeded. In other words, we're getting more accommodation on the site with these ground scrapers, and the amount of social amenity, which can be quite easily measured, green open space per capita, public open space per capita, seasonably occupiable space, such as conservatories or sun spaces per capita. There's all sorts of environmental measures that we've been developing over the years, and it works quite well. There have been mistakes. As I said, we weren't anticipating climatic change as fast as we did. Some of the client missed the roof light openers off. So although the windows are designed, the roof lights are designed to open, they never actually, the openers never got fitted. But on the whole, it's the passive environmental principles are what makes this development worthwhile. So it's the architecture and the building fabric first strategy, which is the message here. All of the mechanical things, such as the wood chip fuel combined heat and power plant, which were claimed by all the environmental consultants and technology manufacturers, broke really quickly. So what's interesting is simplicity and minimizing reliance on technology if you can. So here you can see the, as suggested by another speaker earlier, you've got the flat above or the balcony above, shading the real elevation, which is set in 1.8 meters. You've got 2 layers of double glazed screens. You've got a seasonably occupiable sun space, which can increase the floor area of your living room. And then you've got exposed radiant concrete soffits and floors, which gives you a very good element of passive cooling. And then we incorporate enough solar electric panels on the building surfaces without affecting daylight to power pretty well an electric car for everybody who lives there. There's a they're not all running on electric cars, but they have the opportunity to over time. So the energy for an electric carpool will come almost entirely from the roof integrated PV. So with these simple ideas, we then developed a range of tools which can really be used on a whole range of different other constructional systems, solving different problems, different densities, and so on. And we started off working with Masonry because we felt that was a pretty standard. In the UK at the time, everything was made in brick and block. We developed a special wall tie that hooked in so you could build the outer leaf independently of the inner leaf, and then that went on the market. We do full fill cavities using rock wool. We developed, we managed to persuade a major window manufacturer to offer photovoltaic cells integrated within a wooden system rather than an extremely expensive mainly German aluminium systems. We used recycled steel taken from other construction sites and demolition sites and refabricated it with re-welding end plates on, and that had a major reduction in carbon footprint. We used reclaimed timber, which was a real fight actually for all the internal stud-work partitions because the developers and the contractors desperately wanted to use light gauge steel framing, but this really created quite a lot of employment. We spent a lot of time with the National Physics Laboratory in Teddington on developing a wind cowl which turned down to 1.5 meters per second ambient wind speed, so it had always had positive pressure at one end and negative at the other. And we've tested all the ductwork systems with tracer gas to check that it met the building regulations for minimum ventilation requirements. So this is a lot of work to put on some poor architect trying to design social housing, and no one's paying for it other than us. You know, we do this work because we are trying to get things better. That's an infrared shot, and BedZED. Even the glazing systems on BedZED are warmer in the middle of winter than the insulated walls on the adjacent volume house builders' blocks. So BedZED is far from perfect, and it can be better, and we've learnt a lot from this process. The first thing, perhaps, is not to believe it when someone tries to sell you very advanced high technology. The second thing is to don't rely on a public utility to run grey water treatment plants or black water treatment plants unless you can help it. All of which were integrated into this. So this is a little power station. It's also a grey and black water treatment plant. It's also a community centre. It's also a community kitchen. It's all the communal facilities. The combined heat and power plant, I think, probably worked for about 6 months and never reached full output. It was very much a prototype sold as a viable thing, and the company that fitted it then promptly went bust. It worked on local wood chip, which was supplied from urban tree waste, which was the easy thing. However, you can't write off this because now new technology is such that you can get a very nice Austrian, note the nationality, wood pellet machine that does exactly the same job and is reliable and produces large amounts of hydrogen-rich methane gas, which can go into a conventional CHP gas engine. So that totally ties up with the ideas that you heard earlier today from the gas, that the gas grid can be supplemented with organic gas that is actually generated from renewable energy sources. And on subsequent projects, we also use wood pellets in the normal way, using wood pellet boilers. So that's really a short history of BedZED. From an urban design point of view, it broke every rule there was in the British urban, what makes good urbanism. But we've tried very, very hard on the placemaking agenda, and we maintain that actually it's a lot better than some of the traditional, perhaps more conventional urban projects, which are obviously promoted as best case study exemplars. Now, this is important. This photograph really matters to me because this shows what happens when you don't take BedZED seriously. So the building in the middle distance is a brand new incinerator, and it's the first one planet incinerator. So the local community, or the 4 London boroughs that surround this project, completely failed on their recycling targets and have just basically decided to burn all their organic waste. In a 100-metre high chimney, which then dumps quite a toxic plume over very high density areas of southwest or South London, particularly Croydon, which is mainly Labour and mainly immigrants. So what's actually happened is the political elite have pushed the pollution to the people who are least likely to, 1, vote for them, or 2, complain, with the lowest income generating. And this is, in a different way, this is environmental fascism as well. So there's no need for it at all. The lobby, there's been a massive lobby against it, which we've lost. And they've put in this is one of the problems of working with environmental groups. Because it's a one planet project, they put in a large district heating scheme, which is going to come from the incinerator, but they didn't do their calculations, and they found that the surrounding urban grain was too low density to justify the installation of the heat main. And guess what? The whole thing won't be fitted, but that was the key ingredient that got it over the carbon footprint planning criteria. So this is a game, and it's a serious one. And if we keep losing like this, we really are in trouble. What we've done since then is perhaps more optimistic. This is a house kit. This has just been built at the BRE in Watford. You can build it with nothing more than a screwdriver. And we've completely given up with governments. We've completely given up with standards because we've worked out how to build houses which don't have any net annual energy bills. And if it doesn't cost too much more to make these houses, why wouldn't you build them? You don't need to worry about, concerning yourself with carbon taxation and this and that, because actually the cost of electricity or the cost of energy is rising steadily, particularly in the UK, and the cost of building integrated renewable energy and electrical battery storage is coming down. Again, nothing to do with our country, but it's because economies of scale are being reached in other countries, particularly the continent and China. So what this shows is a house that looks like that, with a slightly eccentric south-facing roof surface, it's an east-west facing home, can generate approximately twice as much electrical energy as it requires to run it over a year, which makes it safely climate neutral, but it also provides the total renewable energy generation is about 8 megawatt hours a year. The total self-consumption for running the home is about 4 megawatt hours a year. That leaves you 4 megawatt hours a year to run your electric vehicle that gets you to work in the first place. So we see this as a game changer. We think the idea of regeneration projects that don't have any energy bills is possibly a politically acceptable way forward, no matter whether you believe in climate change or not. And the current, that is not the case in the United States, and it's not the case in London at the moment. The current political administration are starting to question whether climate change is happening. So conversations that we've had 20 years ago are resurfacing. So underneath this roof, you have a solar conservatory, again in an unheated space, and we've worked out how to build these homes using very short lengths of relatively low quality timber, which are put together with a laser cut galvanized steel ring beam system. Very, very quickly, you can build a floor a day with 4 people. And I think this shows how a timber frame can be democratized. Nothing more than an electric screwdriver. We chose a builder straight out of the telephone directory, so they'd never built any of these kind of homes before. BRE have tested the air tightness, 1.3 air changes per hour at 50 pascals test pressure. It's a forgiving construction technique. We clad the thing in this red skin, which is self-adhesive, vapor-permeable air tightness barrier, and then we put wood fibre or rock wool external insulation, and then rain screen. So that's how we do it, and pretty well anybody can build this kind of home. Very, very affordable. So you don't have to then require any special pleading. You don't have to change the building regulations, because if we have this on the market next door to the product of a volume house builder, no one is going to buy the other home. Why would they? Because the average energy bill in the UK is somewhere between £1,500 to £2,000 a year. That's the family holiday. So what's changed is that the cost of connecting to the electrical grid is about minimum £6,000 per home. The cost of the roof is probably only about £2,500 more than if you put a roof there anyway, because you don't have to buy a roof because it replaces the existing roof surface. And the cost of the battery storage has come down, and it's now about £500 a kilowatt hour, and we put in 1 kilowatt hour of battery storage for every kilowatt peak of photovoltaics. So this is a smart grid inverter system. It's programmed to only connect to the electric grid in the middle of the night or whenever you tell it to. And it can be switched on by an electric utility and told to export at times of peak electric shortage. So with these ideas, you can then completely change what architecture does, because the urban design and the construction and the specification of the services package starts to, you don't need power stations. The very grid itself will start to minimize in importance. In fact, we have debates in the office now. Do we really want to connect to the grid? Do we not? Will the client pay for a substation or not? And we've never found a substation that costs less than $100,000. So thermal bridging, very, 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 very serious. That's now resolved. We don't, as such, need space heating anymore. Material costs are coming down to the point where there could be, at scale, no net increase over the cost of conventional homes, and it's sufficiently traditional in appearance for the non-elite general public to be able to choose it without concerns about it being too radical or too threatening. And what we're working on now is putting these house types into 3D models, and then the local community can literally design their own streets. And we're working with a very disadvantaged community in Hastings in the south of England, near the sea, on the Ore Valley regeneration to do exactly that. So these are near Hastings Castle. These are just being completed, so these are zero energy bill homes. It starts to show how the typologies can adapt to more complex and difficult sloping sites. And we're working now on village-type models where the... have you got vehicle to grid yet in Canada? Do we have electric cars that you can plug into buildings and they power the buildings? Anyway, well, this is just starting to come in the UK, and we're working with a car manufacturer. And you don't even need to put very large batteries in the buildings anymore, because if you've got 40 kilowatt hours battery storage in a Nissan Leaf, which is a perfectly ordinary electric car, and you're only using, say, 5 kilowatt hours of that 40 kilowatt hours to run the home, then it's plainly a really good system. So the integration between reducing urban air, reducing fossil fuel emissions in city centres, and changing over to electric vehicles really starting to look good. There's a virtuous circle there. So these different typologies we're going to make, they are now available. We're building one-offs, so this is the sort of thing we're doing at the moment, where quite complex small-scale projects are built using the same construction system. And we've gone into larger-scale projects now, showing how those components can then solve much larger problems. So if you redesign the extrusions that go around a solar panel and they integrate, they fit together in a careful way, you don't have to buy a roof, because the solar panel actually is made out of durable materials and sheds water really well. And if you then integrate clear glass so you can adjust daylight levels underneath the solar roof, then a little village, this is a village in China, this village is entirely run off this bus station roof. And then you can start replacing existing buildings, you can start taking slate roofs off and putting these tiles in, you can start covering over streets so that you don't have to put solar farms in the landscape, taking agricultural land. You can use the very large areas of land already asphalted over, and they're either used as roads, they're used as parking lots, they're used as there's huge areas that I've seen coming from the airport in Toronto, the vast areas of tarmac. So old school puts all of the renewable energy as separate, expensive items that have to be justified under their own business plan. Then what I'm suggesting is that the new thinking integrates it within the urban design. This is a coal-burning power station site that we're trying to regenerate as a village. So underneath the solar farm, it looks like this. So you have daylight on the north-facing slopes, photovoltaics on the south-facing slopes. It's a holiday village, so you can sleep in camping balls suspended from the roof. And you can also get the same concept to power refrigerated containers, and this is a village centre in Brazil. This is a football stadium, so you can now see how very ordinary buildings which are required just for running a contemporary lifestyle can be adapted. And what was important about this was the footprint of the football stadium was mainly that it had no direct public transport connection, so we could entirely power a very large fleet of electric buses, which got all the fans from the local railway stations to the match and back. And I think that kind of thinking, and then when obviously a football game isn't on, then the stadium can be used as an exhibition centre or a solar power station which runs the surrounding urban grain. And we're moving now away from, contradicting myself, but we're moving towards solar trees, where we're putting the lithium battery banks inside the tree as ballast, and we're using those to power smaller off-grid communities, but also residential areas where the architecture was never designed to be upgradable to modern energy efficient roofing systems or energy generating roofing systems. And this idea is catching on now. So you don't have to necessarily do the Dutch system, the energy sprong, where you clad an existing building in solar panels. You could put the tree in the garden. So bringing this forward, can you develop a cladding system which integrates triple glazed windows, roof lights, shading systems, solar powered cooling systems, super insulation? Can you pull it all together, and can we use that to renovate the existing building stock, which is frankly the majority of the problem if we're going to meet our carbon targets in time to stop accelerating climatic change? So what we're doing at the moment is subtly changing the design of the BIPV cladding system to move into the vertical plane, do walls and roofs and sun spaces with a sort of easy fit together kit, and we're using that on a converting. It's actually a love hotel, which is being converted into a maternity hospital. Which is kind of logical. But so where we're going is making these components really quick and easy to accept. But what's now becoming exciting is no one has any money. So how can we fund this? No financiers will fund. None of the clean tech investment companies are interested. But the big market is actually the developing world, particularly Africa. And what's actually becoming clear is 1/3 of all the lights in Johannesburg go off every night due to load shedding, because they haven't got enough electric generating capacity. So we're working on a new concept, which is a tiny battery. It's 1 kilowatt hour. It fits your electric bike. It clips onto the wall. And you literally can take a city off-grid room by room. It plugs into the wall. so it can charge up from the grid if there's no solar, or you can hang a solar panel over your balcony, or you can hang a solar panel as a brise soleil integrated into your flashy architectural design. You can take the battery out and put it into your e-bike, which gets you home again or gets you to work. And we think this changes the dynamic, because you don't have to get involved with power companies. You can bypass them. You can design all this stuff out, because what's expensive on a smart grid battery inverter is all the electronics, which has to synchronize with the AC grid. And I think, I'm interested to know what the electric utilities will think about this, because if you've got no money, it's going to be a lot cheaper. Your annual electric bill can be replaced with a couple of batteries, and you'll just be fine. And then you can go on, and by developing lighter weight ways of using this 1 kilowatt hour battery system, you can have cars that more resemble motorcycles perhaps than cars. And you suddenly find that you don't need to buy a Tesla with 50 kilowatt hours of batteries, or a Nissan Leaf with 40 kilowatt hours of batteries. Actually, you're just fine with 3 batteries of 1 kilowatt hour. And then you don't even necessarily need to own the batteries, because actually you could have just rented them and got them out of a battery dispenser, which happened to be underneath your solar farm, which goes over your street. And suddenly the whole thing, because you've minimized demand, it starts to work. And if you look at the cost of pretty well any off-grid cordless electrical appliance, I bet you're all rushing out to buy your Dyson vacuum cleaner or your expensive power tools that they're all cordless. Every time you do that, half the cost of your purchase is the lithium battery. And all that can be replaced with this thinking. And it can all be charged pretty well from renewable energy systems. So that's where we're going. And the results are I think, it's very low cost. It's not for everyone, but it is definitely a good way of improving air quality in a city without making massive investment. You've just got a few of these battery dispensing docks and charge points for electric bikes and lightweight electric taxis and these sorts of things. And if there's anyone out there that wants to get involved, then tell us, because we can't do this stuff by ourselves. We look for partners that want to get involved, and together we can solve a big problem. But if everybody just simply sits and competes in their individual silos, then nothing new happens. So, for example, there's a particularly good Canadian free-wheel trike. It doesn't tilt when you go around corners, but it probably could do. But you can run this stuff off this kind of thinking. And the Chinese housing minister said, well, okay, how does this change the design of an apartment block? Well, you put the cars in the lift and you drive up to your front door, and that's the new kind of thinking. So that's what we're doing. I've been told to speed up, so I'll just show you the final thing that we're working on. No, it's good. It's good. So this is what makes it affordable. So we found that there's no land available in the UK. This is really the biggest problem, and there's nowhere for young people to live, and they can't borrow any money. So what we're doing is we're building. I've got together a fund. We're building above parking lots with a special steel structure, which is removable, with a solar farm over the roof, and pretty well anybody can afford to live in one of these homes because it's the same price as renting a room in a shared house. And that still gives the investors the return on investment that they require. So what this suggests is that where, and it's not made out of materials that kill you, such as urethane foams. So Canadians, stop using urethane foam, please. So with pop-up factories, local labour, there's a massive opportunity for Canada to supply some of the ingredients for this kind of thinking, and it's extremely, there are 1.2 million parking lots in the UK. We're getting a conversion ratio of for every 5 parking lots, we get 1 home. And that means you can house about 250,000 people. So I just propose to you that all these ideas are not out of question. They are actually possible. They are actually fun. They are actually viable. And you just got to get on with it and do it. And you can apply all of this to existing buildings as well. It's the same thinking. And you can even float your communities. This is the first floating block of flats in London that we've just built. Anyway, the presentation's on your website, so you can amuse yourselves later